After discussing the torque and angular momentum for a system of particle, let us try to establish the relation between these two quantities. The torque changes the angular momentum. The torque is the cause of angular momentum change. The angular momentum of a system of particle changes about any reference point when the torque about that reference point experienced by the system of particle is non-zero. Let us assume that the system of particles let us show in the diagram the ith particle which moves with velocity vi, and with respect to the reference point O, its position vector let be Ri. The angular momentum of ith particle about O is Ri cross MIVI. If you take the vector sum of all the angular momenta or angular momenta of all particles about this point, you will get the net angular momentum. The net angular momentum of the system about O can be written as sum of angular momenta of all particles, that is equal to sum of Ri cross MIVI. Let us differentiate both sides with respect to time. Time derivative of this quantity in right hand side. This can be written as sum of the time derivative of Ri cross MIVI. It doesn't make any change. Let us differentiate this term. We know that derivative of cross product of two vectors is equal to vector A cross derivative of the vector A cross vector B plus vector A cross derivative of vector B. By using this vector equation or the vector expression, we can write this term as sum of dri upon dt cross MIVI plus Ri cross d by dt of MIVI. Since the rate of change of position vector is known as velocity vector, we can write rate of change of angular momentum with respect to time about the position O is equal to sum of this quantity is the velocity vector of ith particle cross MIVI plus sum of Ri cross d by dt of linear momentum of ith particle. Since Vi cross Vi is 0, this term will vanish. Therefore, we are left behind with the term in right hand side, which is equal to sum of Ri cross rate of change of the momentum of ith particle. The rate of change of momentum of ith particle is equal to net force acting upon the ith particle. So you can write summation or sigma Ri cross Newton's second law states that whenever a net force acts on a particle, its momentum changes, and that force is equal to rate of change of linear momentum of that particle. So we can just write force, net force acting on ith particle. Ith particle may be interacted by the other particles. Therefore, on ith particle, the sum of all interaction forces due to other particles of the system can be called internal forces. So this net force acting on ith particle can be written as internal force, and the forces acting on ith particle from outside, say like this, on ith particle. When sigma term is there, we can write Ri cross force acting on ith particle from outside, summation of this, plus Ri cross force acting on ith particle from inside, that is called internal force. And this term is none other than the external torque. Sum of this is the torque acting on ith particle, this is the sum. Sum of torques experienced by all particles due to the external forces can be written as external torque. And this second quantity, the second factor, gives us the sum of the torque experienced by all particles due to the internal forces. And since the internal forces, they always appear as pairs, action reaction pairs. They are equal in magnitude, oppositely directed and collinear. Therefore, they cannot produce a torque as a whole about any point. That thing already we have discussed. Therefore, this factor is 0. This is called internal torque. And we have proved that the internal torque is equal to 0 and the external torque will be responsible for changing the angular momentum of the system about this point. Therefore, the rate of change of the angular momentum of the system of particle about a reference point O is equal to the torque experienced by the system of particle by the external forces only. We can call it net torque or torque due to the external forces as a whole. This is called the Newton's second law for turning of the system with respect to this point. Now, using this theorem and some allied theorem we discussed previously, we need to concoct the theory of translation and theory of rotation of system of particles. Therefore, in words we can say that the rate of change of angular momentum of a system of particle with respect to or about any reference point, preferably inertial. Is numerically equal to the net torque experienced by the system due to the external forces only, because the sum of torque produced by all internal forces, that is the tau internal, is equal to 0. Due to the external forces only, because internal torque is 0. So, this is the statement of this mathematical expression in words.